Hi, this is Jeremy. I'm here to talk about vesicular membrane transport. That is movement or transport of materials across the cell membrane using a vesicle. Previously, we have talked about passive membrane transport that requires no energy. We've talked about active membrane transport that requires energy, either in the form of ATP or some concentration gradient. Vesicular membrane transport is different. I might consider it a subcategory of active membrane transport simply because it does take energy, but it's a different thing altogether. With the other types, we've talked about moving ions through channels or glucose through carrier proteins, sometimes sodium being pumped out as in primary active transport, or sodium and glucose coming in together with secondary active transport. Vesicular transport, on the other hand, is when you have a whole new thing all together. Something that's just too big to get in. Let's say this is a real small breadcrumb or something. No matter how small that is, it's not going to fit through this channel. It's not going to fit through this carrier, which means it also is not going to fit through either of these proteins either. So I need to do something completely different. And let me add to my cell here a little more flexible membrane than the one drawn on there. I'm going to pretend this yarn is my membrane. Now the membrane protects the cell. Remember, it's selectively permeable, so it's adding that barrier of protection around the cell. We don't want things coming in and out freely. I also can't punch a giant hole in this membrane in order to let this thing in. And so I'm going to make a vesicle out of it. And this will be an example of endocytosis. There's a couple different varieties, but we'll stick with the basics for now. So that's one type of vesicular transport. So as this large object comes into the cell is going to be pulling on this with little microtubules inside the cell. So it is spending energy. Notice the membrane is not disrupted. There's no giant holes in it. It can be pinched off here, and then we need to make a couple of quick cuts, making sure that we don't completely ruin our membrane. Yep. One more snip. There we go. Now I have this breadcrumb inside of my cell, and I can do something with it if I want to. I can add some enzymes to this vesicle, or leave it alone, do something else with it, move it somewhere else. So there's endocytosis. Well, let's take the opposite situation. Maybe the cell didn't like it, and so it wants to spit it back out. An obvious name for that would be exocytosis. And so we'll push it back out using microtubules and such, merge that vesicle with the membrane, spits it right back out, but the membrane's not disrupted. We didn't poke a hole in the membrane, and so the cell is still safe. There's some nuances you can add to this, but that's the basics of vesicular membrane transport, coming into the cell by endocytosis or out by exocytosis.